Hi everyone, this is a last minute Lucy review for our big test coming up for analytic trigonometry. So let's get started. We have a lot to cover. Let's see. First thing is that you're going to be able to use this trigonometry identity sheet during the test. So you are welcome to know these, but you don't have to memorize these specific identities because they will be given to you. We're going to just start off with very quick review on what these points are. Remember, this is 1, 0 for our point on a unit circle. This point right here is going to be root 3 over 2, comma 1/2. This point is root 2 over 2, root 2 over 2. And this point right here is going to be 1/2 root 3 over 2. And so just remember that this being either, if you're in degrees or radians, this 0 degrees or 0 radians. This right here would be your pi over 6 because that's 30 degrees. This is your pi over 4 or 45 degrees. And this would be pi over 3 or 60 degrees. And then of course you've got your 90 degrees and this would be 0, 1. And then remember that once you know that first quadrant, every other quadrant, it has exactly the same base numbers, just the signs are all different. So meaning if you go towards the left, all of these would be the same values except for the cosine values, which is the first. Remember, it goes cosine, comma, and then sine. The cosine values would be negative in this quadrant. So you'd actually have negative root 3 over 2, comma, and then sine would be 1/2. And then to get to that value, although you have a pi over 6 or 30-degree reference angle, the angle is pi over 6 less than a whole being 1 pi. And so this would be 5 pi over 6, right? And then going backwards, of course, this would be a fourth short or 3/4 pi. And then, of course, on the top would be 2 pi over 3. And so review that and even listen to the songs that we sang in class because those are really important that you know all the way around. This quadrant, remember, in this quadrant down here, only tangent is positive, and the reason for that is because sine and cosine are both negative. So this point right here would be, for this one, you'd have negative root 3 over 2, comma, and negative 1/2, etc. And then in the right side, only cosine is positive and its reciprocal function, which is secant, in this quadrant. So all of the cosine values would be positive, so root 3 over 2, but all of the sine values would be negative, so that would be negative, so all the way around. So we're going to start off with finding the exact value within the restricted domain. So for sine, the restricted domain for sine is the first and fourth quadrant. So from here to here, negative pi over 2 to pi over 2. And so this is asking me, where is sine? They're asking me where. When they ask me where, they're asking me for the angle at which sine is root 3 over 2. Because that's positive, this negative quadrant's out. So where are we? Sine, and again, you just looked at the quadrant. You should know that that's going to be pi over 3 or 60 degrees, depending on how they ask you. Do they want the answer in degrees or radians? Okay. But another option for finding that is, you know that sine is opposite over hypotenuse being 2. And then the opposite side would be root 3. The angle opposite root 3 is 60 degrees. So that's another way for you to think about that. Always opposite 60 degrees is root 3. Always opposite the 30 degrees is 1. Depending on which quadrant, again, that will make the values positive or negative. In this question here, it says, where is tangent negative root 3 over 3? So also, like sine, tangent has this first and fourth quadrant restricted domain. So this is out on top. They're asking me, where is tangent root 3 over 3? Now, in class, we talked about root 3 over 3, 30. And I hope you remember that because root 3 over 3, 30, that means 30-degree reference. So I know that my reference angle is going to be 30 degrees, okay? But how do I get down here? I'm going to say either negative 30 degrees or I'm going to say negative pi over 6. Now, of course, not everybody knows this. And for those of you who are watching who aren't in my class, who weren't there, what I'm saying when it says root 3 over 3, What was the question? The question was negative 1 over root 3. That's where that came from. And then they simplified it and said, oh, don't leave a root on the denominator, etc. So what ends up happening is tangent is opposite over adjacent. So this side here would be negative 1. This side here would be root 3. And this would be, of course, 2. Which angle is across from the negative 1? Again, 1 is going to be 30 degrees. In this question, it's asking me where is cotangent root 3. Again, like tangent, cotangent has the same restricted domain, and so therefore this is over 1. And so you know tangent's opposite over adjacent, which means cotangent is adjacent over opposite. Because this is positive, this is negative. That's not negative, so we're in the first quadrant, and therefore cotangent, the adjacent side is root 3. The opposite side is 1, therefore that's 2. Which angle is opposite the 1? That's the 30 degrees. So I would say positive 30 degrees, or I would say pi over 6. In this question right here, where is cosine root 2 over 2 negative? Remember, cosine, arc cosine, has a restricted area or domain of 0 to pi. And so therefore, this is positive, everything's out there, but this is negative. And so what they're saying is, we are in this quadrant here. Where is cosine root 2 over 2? And so cosine is root 2 over 2 at a 45-degree reference angle, which means that from here to here is going to be 3/4 pi. Or, of course, you could always say 135 degrees. For this problem here, this is two-step problem, because first they're asking me where is cotangent 4 over 5. Now, one of the things that I do notice is that 4 over 5 is not one of my 30, 60, 90 or 45, 45, 90 right triangles. So what that means is, therefore, when it says where is cotangent, first of all, it's positive. And because it's an arc cotangent, again, I do have a restricted domain of negative pi over 2 to pi over 2. But negative is out because it's positive. And so where is cotangent 4 over 5? Remember, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So the adjacent side is 4. The opposite side is 5. Now, this looks like it could have been a 3, 4, 5 right triangle, however, one of our triples. But it's not, because if this was a triple, the 5 would have to be my hypotenuse. So watch out. It's a little bit of a, throwing you off a little bit. But in order to find that third side, I would use Pythagorean theorem, which is a squared plus b squared equals c squared. So 25 plus 16, right? 25 plus 16 is 41. And so that's the square root of 41, which you just leave it like that. So the question that says, where is cotangent 4 over 5? Here. So you're here at where cotangent is 4 over 5. Now, this is asking me what is secant. That's what it's saying. What is secant? The negative 1 is saying where or what angle. Secant is saying what is the exact value of where I am. And remember, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So what this question is asking me is, what is the hypotenuse over the adjacent side for where I am? So that's going to be root 41 over the adjacent side, which is 4. And then this would be my final answer for this two-step problem. This one right here is inside first. Do the inside first for these problems. So this right here is saying, where is cosine 1/2? And so cosine is 1/2. Remember, cosine has a restricted domain of 0 to pi. This is positive, so that means my negative section is out. So what we have here is a first quadrant. Where is cosine 1/2? Now, you may remember that sine of 30 is 1/2. So therefore, it can't be, 30. It'd have to be 60. So therefore, I'm at 60 degrees. Another option to remember what that is cosine is adjacent over hypotenuse, which means it's 1 over 2. and therefore this side is root 3. And of course, across from the root 3 would be a 60-degree reference. So where am I? I'm at a 60-degree reference. So I'm at pi over 3 or 60 degrees. So if you prefer radians or if you prefer degrees, either way is fine. So this is now asking me what exact value is sine of pi over 3. Well, sine of pi over 3 is equal to root 3 over 2. And so that's what sine is, where cosine is at 60. This problem here is saying, where is cosecant negative 5 over 3? So I'm going to draw my graph because cosecant is the reciprocal of sine. And therefore, it has the same restricted domain, which goes from, again, negative pi over 2 to pi over 2. And so this is asking me, where is cosecant negative 5 over 3? Well, this is positive, so that's out. So where is it negative? Now, again, sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So in this quadrant down here, my hypotenuse is now 5. The hypotenuse in a right triangle is always positive, which means that this negative sign, that 5, is actually going to be moved to that negative 3. Totally fine. So hypotenuse over opposite, so there's negative 3, and this is a 3, 4, 5 triangle. So we did this. They asked me where I am. I'm here. So I'm here at this axis right there. Now, this part of the question is saying, what is tangent of where I am? Now, tangent of where I am is opposite over adjacent. So my opposite side from where I am, and this is me, is negative 3 over adjacent, which is 4. And so that would be my answer for that problem. So we're going to switch over to some sum and difference formulas, finding the exact value again, but sum and difference. So this might be, if you don't have your identity sheet memorized, this is where you would have that in front of you maybe. Cosine of 195. So I'm thinking that what would make 195, and there's so many varieties. I'm going to actually use cosine of, I think, 225 minus, is it 60? What is that? 225 minus 60. Nope, that's not it. So I think maybe 225 minus 30. Let me see, right? That's 5. That's going to be a 9, 195. Okay, so 225 minus 30. And so that's how you figure it out. You just kind of guess and check what's going to make, 195 degrees. And there's so many different options. Of course, you've got so many options. So this is a difference formula, but the only time you use this minus sign is in the middle when you're changing from when you're using the formula. So if you look at your formula, cosine of this is going to be cosine, cosine, sine, sine. And so this expands to be cosine of 225 times cosine of 30. And because it's minus here, this sign does change to plus. And then it's going to be sine, of 225 degrees times sine of 30 degrees. And now all you have to do is actually plug in the values that you know. And, you could completely draw two little triangles here, right? For 30 degrees, I'm right here. And remember, a 30-degree angle, opposite 30, a 30, reference is 1, this is 2, this is the square root of 3. Opposite 225, let's see, 225, all the way around past 180 down here, that is a 45-degree reference, which is 1 square root of 2. However, in the third quadrant, both sine and cosine are negative, but going to the left is negative, going down is negative. So that means 1 square root of 2, I've got 1 square root of 2. That's where I'm at. So cosine of 220, did I say? Yeah, that's 45. Cosine of 225 degrees is adjacent over hypotenuse. So that's going to be negative root 2 over 2. Cosine of 30 degrees is going to be root 3 over 2. That's positive. So when I'm talking about the 30-degree reference, I use this graph. When I'm talking about the 225-degree reference, I use this graph. plus sine of 225, also negative root 2 over 2, times sine of 30 is just opposite over hypotenuse, which is 1/2. And just to simplify this, we end up getting, I'm going to move this down a little bit. Okay, that's easy for me to do, right? That's going to be negative root 6 over 4. You just multiply the roots together, keep that negative sign. And then this is negative times positive, also negative, root 2 over 4. And I can simplify this to combine the two numerators and denominators, meaning I have the same denominator, so my denominator is 4. So I would just say root 6, negative root 6 minus the square root of 2, and leave it at that. That's your answer. I mean, yes, you can factor out a negative sign if you want, but there's no reason to. For the next problem, it's asking me for sine of 105. And so again, this is another sum formula that I'm going to use. So for sine, remember sine goes sine, cosine, sine, cosine. So, and I need to make 105. So, and this was a little bit easier than the last one, which was to make 105, I think I'm going to use 60 plus 45. And yeah, that's 105. And so I can use that. That's what I'm going to use. So I'm going to say, well, this equals sine of 60 degrees plus 45 degrees. And so expanding that, that's going to be sine of 60 cosine of 45. Sine has the same sign. Cosine had different signs. Remember, that was a minus and this was a plus, but the formula for sine is the same. So that means that this plus here means that's also plus. And then the other one is going to be, I use sine of 60, now I'm going to use sine of 45, and this is going to be cosine of 60. Now, I know a lot of the formulas are written such that cosine goes first on the second one, but multiplication is commutative, so I like sine first. So sine of 60, root 3 over 2, cosine of 45, root 2 over 2, plus sine of 45, root 2 over 2, cosine of 60 is 1/2. Now, if it makes you happy to, redraw the graphs, you should. Meaning I can draw a 60-degree graph right here, which means 60, opposite 60 is root 3, this is 2, this is 1. 45 degrees would be 1, 1, square root of 2. So if that makes it easier for you to, fill this in, absolutely you should. So this is root 3 times root 2, which is root 6 over 4, plus root 2 over 4. And again, I absolutely can combine those because the denominator is the same. So root 6 times, or add root 2, all over 4. And, of course, there's also, you can check your answers because, you can look up on your calculator what sine of 105 is, right? What decimal equivalent that is. I'm thinking a sine wave looks like this, right? This is 180. So 105, that's 90. So 105 is like right around here. So, I mean, what is that going to be? It's going to be like 0.7 or something like that. This, when you add these up on your calculator, again, make sure you use parentheses, and divide by 4, you should get the same value because, sine of 105, these are proofs, basically, right? We're not finding anything, we're not finding a new discovery. We are proving something and just manipulating it to write it a different way. All right, now, 100%, this is probably the hardest problem we're going to take on the test. Not because it's difficult, just because there's so many little steps. Because this is a sum formula for cosine, because see the sum in the middle, right? And what that tells me is that the middle value, again, if it's positive here, that'll be minus. And that's what I'm doing. I'm taking that value and I'm expanding it. I'm going cosine of A plus B, right? I'm expanding that. And so it should be cosine, cosine, sine, sine, right? And so this is how you're going to do this problem. You're going to say cosine of A. This is A. This is A. This is B, okay? So cosine of A, which is arctangent of 3/4, okay? And then cosine of B, which is arcsine of negative 8 over 17, okay? And then of course, it goes sine, sine. So the second part of this is going to be sine of arctangent of 3 over 4. And then it's going to be, let's see, sine. So sine of sine of negative 8 over 17. Like that. Okay? So now we have all of these little inverses that you guys should be pretty good at. But just for fun, and not everybody has to do this, but I'm going to make my two angles because I want an angle that's going to represent the A, and I want an angle that's going to represent B, which is the sine and the tangent. So the A value, here's my B value. So the A one is saying, where is tangent 3 over 4? And so I'm going to say within, remember, it's a restricted domain, tangents in the first and fourth quadrant. So where is tangent 3 over 4? Not negative, it's positive, first quadrant. So tangent is opposite over adjacent. And so that's 3 over 4, which means this is 5. And that's your A. And then for B, I'm going to draw, and it's negative, and it's a sine, so it's top and bottom. And because it's a negative like that. So it's down in that quadrant, fourth quadrant. Sine is opposite over hypotenuse. So that's negative 8 over 17. Also another triple, Pythagorean triple. So the 8, 15, 17, right? All right, so now that I've got my graphs here, this is my B angle and this is my A angle. And so now I just have to expand it, do this. So this is saying, where is tangent 3 over 4? Right here. This is it. You go, hey, I'm right here. This is saying, what is cosine of where I'm at? Cosine is adjacent over hypotenuse. So this whole thing here is now 4 over 5 times, where is sine? Negative 8 over 17. Sine over here is going to be negative 8 over 17. That's where I'm at. I'm right here now. What is cosine of where I am? Cosine is 15 over 17. So this will be 15 over 17. Minus, now I got to do my sines. So this is where I'm at, where is sine 3 over 4? Well, right here. What is sine of where I'm at for tangent? Well, sine is opposite over hypotenuse, so that's going to be 3 over 5. This one is saying, where is sine negative 8 over 17? Right here. What is sine where I am? And this is going to be, of course, negative 8 over 17, because those are the same value. So now I just have to multiply, right? I'm going to be multiplying what, let's see, 15 times 2 is 30, so 15 times 4 is 60. This is minus negative 24, which makes plus 24. And then 17 times 5, 5 times 7 is 35. Add 3, we get 85. So this is over 85. This is over 85. And so 60 plus 24 is 84 over 85. And so that's my final answer. Right on. Very tricky. Okay, we're going to move on to expressions. And so expressions are not solving anything. You're not solving anything. All you're doing is simplifying what you already have. And so simplifying what I already have is this. And I notice that it is quadratic. I've got a cosine squared, a cosine, and a number. Now, you can use u substitution, which means I would say u is equal to cosine of x. Meaning, instead of seeing it like this, I would see it like this. I would say u squared minus 2u minus 8. And then I would factor based on this u substitution. And so go, oh, u times u is u squared. What times what is negative 8? Well, it's got to be a plus and a minus. That's going to add up to be 2. So this one is going to be 4 and 2. So negative 4 and positive 2 is going to be, let's see, negative 4 add 2 is negative 2. So that's what I would do. And then I would plug back in my u substitution. But you don't have to do that. It's just an option, because some kids will just go, well, I know cosine of x times cosine of x is cosine squared. Check, that's that. Negative 8 is going to be a plus and a minus. To make a negative 2, also, I'm going to go a negative 4 times a positive 2. Now, all of this is over cosine of x minus 4. And so, therefore, this quantity, and do not cancel individual values. You cannot do that. This is a quantity. You cannot break into that. But if the quantities are exactly the same, then I can cancel this quantity with that quantity, and they make 1. And then what I'm left with is cosine of x add 2. And then that's my final answer. I'm not solving this. Do not add a 0. Do not add an equal sign. If there is no equal sign to start with, do not add one. Okay? All right. All right. These are 2 more expressions. No equal signs. On this one's a little bit different than what we've done. These are using odd and even functions, but what most important is that you remember that cosine of a negative value, any negative value, is going to be positive cosine of x, whereas sine of a negative value is going to be negative. Okay, and so tangent is sine divided by cosine. So that's a negative divided by positive, so that means that's positive. So I'm going to actually rewrite this. Cosine of negative t is just cosine of t, because now cosine is positive. And secant is a reciprocal of cosine, also positive. So now I've got positive secant of t. Tangent, however, is negative, because that's sine and negative divided by positive. So this is minus tangent of t. So for this problem here, I can simplify it. I just need to get, for this one, I'm going to change everything to sines and cosines. So this one's already cosine. Leave that alone. Secant is a reciprocal of cosine. So this is 1 over cosine of t minus tangent of t, which is sine of t over cosine of t. So this makes cosine of t divided by, because these are the same denominator, right? I can combine those two. And so that's going to be on the denominator, I'll use a different color, maybe that'll help. 1 minus sine of t all over cosine of t, right? And remember, this division sign here means divide or multiplying by the reciprocal, which is saying cosine of t times, now we're going to take this and flip it, times cosine of t over, what am I doing? Sorry, 1 minus sine of t. And then it looks like I have cosine t over 1. So I'm going to multiply that out, and I get cosine squared of t over 1 minus sine of t. This is like the never-ending problem. Because I actually see that this can be replaced with one of my Pythagorean identities, which is sine squared plus cosine squared equals 1. And so that means that cosine squared is equal to 1 minus sine squared of theta, which, remember, is a difference of 2 squares. And so this then would be changed actually to 1 plus sine of t times 1 minus sine of t. And that's all over 1 minus sine of t, which, oh, heads up, this right here as a quantity will cancel with that as a quantity. And my final answer is 1 plus sine of t. And then box that up. Again, no equal signs were involved. You can, because, you know, if you want to show progression, you can use an arrow. However, please don't add any equal signs if there's no equal signs to start with. For this problem up here, try to make this a little bigger because everything got a little smaller. This is a sum. We just did those. We just did a bunch of those. We're going to do one more. This is cosine of this difference. And cosine of the difference, remember, goes cosine, cosine, sine, sine. So this will go cosine of x, cosine of 5 pi over 2. Remember, do not take that negative sign. You are, the only way you use that negative sign is to change that from negative to positive as the identity asks. And then this one is going to be sine of x and then sine of 5 pi over 2. And so 5 pi over 2 is what? What is 2 goes into 5 twice and 1/2 left, right? And so where am I? Let's see. Here's 1 pi, here's 2 pi, here's a 1/2 pi. Here I am. Where am I? I'm at 0, 1. And so remember, it goes cosine and then sine. And so cosine of x, that's just cosine of x, times cosine of 5 pi over 2. Well, cosine of 5 pi over 2 is 0. And so what this is actually saying is 0 times that value plus sine of x times sine of 5 pi over 2. 5 pi over 2, sine would be 1. So this is times 1. 0 times anything is 0, so that's gone. So now I'm just left with sine of x times 1, which is sine of x. And therefore, that's my final answer. And just to note that on your identity sheet, you would see the fact that this value right here does equal sine of x. So even though you have to show that this equals, what it equals and show your work, you would be able to to verify that that equals that. For this problem here, we're going to simplify the expression. And to simplify this expression, I need to realize that it is a difference of 2 squares, right? And so this being a difference of 2 squares, this would be sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. Now, first of all, this right here is one of my Pythagorean identities, and that's 1. And so that's 1 times sine squared of x minus cosine squared of x. Well, I'm done because I got rid of that, but I might be able to simplify this a little bit. I could try that. Let me try to simplify this. If I wanted to replace cosine squared, I can make that 1 minus sine squared of x. And let's see what I would get. I would get sine squared of x minus the quantity. Don't forget, it's the quantity. This is a quantity. So minus 1 minus sine squared of x. And so I would get sine squared of x minus 1 plus sine squared of x, and this actually makes 2 sine squared of x minus 1. And in looking at your Pythagorean identities, you might have recognized that this is this one of my double identities? I think one of my double identities is for cosines of 2 theta. Remember that one? There's 3 options. And so what I could do is take out a negative sign, and that would give me, let's see, I'm going to rewrite that. First, I'm going to rewrite that just for 1 second. And doing that, I would go -1 plus 2 sine squared of x. So if I factored out a negative sign, I would get 1 minus 2 sine squared of x. And this right here is my double identity, my double angle identity. So cosine of 2 theta or 2x, and this is negative. So, is that any better than this right here? No, not really. So I would just leave it like this. That didn't really, I guess it's 1 term versus 2 terms. So you could do that. For this problem, it is asking me to FOIL, and I will do that. I do want to just say that sometimes it's in your best interest to change everything to sine and cosine. However, in this case, I don't want to change this to sine and cosine because multiplying with fractions, multiplying is hard enough. Let's not multiply with fractions if we don't have to. So we're going to go 1 times cosecant of x, which is cosecant of x. 1 times that, which is negative cotangent of x, is negative cotangent of x. Then this times this is negative. A positive times positive is positive cosine of x, cosecant of x, and then this times this is negative cosine of x, cotangent of x. And so now I have this all foiled through. And what I would do at this point, now remember, there's no equal signs. Do not add equal signs. Is change everything to sine and cosine. So cosecant is 1 over sine of x, minus cotangent, which is cosine of x over sine of x, plus cosine, that stays here. Cosecant is 1 over sine of x, minus cosine of x. Cotangent is cosine of x over sine of x. Well, I'm loving this because all of my terms have sine of x as a denominator, which I love because now, even though I've got, let's see, 1 term, 2 terms, 3 terms, 4 terms, every one of those terms has sine as the denominator. So that means that my denominator is going to be sine of x. And I don't have to change anything. I love that. But on the top, the numerator, we're going to have 1 minus cosine of x. And then I've got plus cosine times 1, which is just plus cosine of x. And then here I've got minus cosine times cosine is cosine squared. So cosine squared of x. Cosine and negative cosine are going to cancel. And I have now 1 and then minus cosine squared of x over sine of x. And I think some of you see where this is going because this is one of my Pythagorean identities, which is equal to sine squared of x. And I now have that over sine of x. And so that means that, and remember, sine squared is just sine of x over, sine of x times sine of x, right? And this is over sine of x. But what that means is one of these signs is going to cancel. See, this sign will cancel with one of those, leaving me just sine on top. Only one is left, so sine of x on top. So this is, definitely better. We just simplified it. So one more expression. This is a division. I think I'm just going to change everything to sine and cosine first and then see what we have. So I have sine of x plus tangent, which is going to be sine of x over cosine of x. And that's divided by this on the denominator, which is 1 plus secant of x, which is secant is a reciprocal of cosine. And so I'm going to put that like that. Now, on this problem, unfortunately, I don't have common denominators. This on the top, not related to this on the bottom. This is a quantity. This is a quantity. You cannot mix and match until you start. You got to combine those into one term so that I can multiply, divide it by the reciprocal. So I need to change this, which is 1, and this, which is 1. I need to change them both to cosine because those are both of my denominators. So this I need to multiply by cosine of x over cosine of x, because remember, you can multiply by 1 but not change the actual equation or expression. And this is going to be, again, I'm going to multiply this by cosine of x over cosine of x. So I'm not going to use equal signs, I told you that, but I am going to use a forward arrow to remind myself progression, not an equal sign. So what I now have on the numerator is sine of x, cosine of x, plus sine of x. And this is all over cosine of x divided by cosine of x plus 1 over cosine of x. Now, some of you, okay, so now I'm down here, more progression. Some of you can see that this cosine will cancel with that cosine, okay? Though, for those of you who don't see that, because I am going to be, this division line right here means I'm going to multiply by the reciprocal. So that's saying sine of x, cosine of x, plus sine of x, divided by cosine of x, See that? That's this top part. And then this division here is actually multiplying by the reciprocal, which is cosine of x over cosine of x add 1. And so this right here does cancel. And so you could cancel it here as long as you see that that's what's happening when you multiply by the reciprocal. I am going to simplify this top part, this right here, because I do see that there is a sign in common. And I'm going to factor that out. And sometimes you do things and, nothing is a benefit from it. But sometimes there is. And so in this case, there is. So I'm factoring out a cosine because a sine, because now I'm left with cosine of x plus 1. And this quantity is going to cancel with that quantity. So I've got 1 times 1 over that. It looks like everything is canceled out except for just sine of x, and I'm done. Now, we're going to switch off to equations, and I believe finish off with equations. Solving for all values between 0 and 2 pi. So instead of my restricted domains, right, for both sine and cosine, I'm eliminating that, and I'm saying I'm solving for all values that are only between 0 and 2 pi, not including 2 pi, which means I include 0 all the way to 2 pi, but not including 2 pi. So your objective is to solve for x. That's what you want to do. You want to isolate the x. And so it's just like solving a regular equation. You want all of your x's on one side. You want anything that's not an x on the other side of the equal sign. And there is an equal sign, so we are solving. So in this problem, I'm going to start off. I see this x sine of x over here. I'm going to move it to be over with this sine of x. So I'm going to add sine of x. So on both sides, I'm adding sine of x, both sides, okay? Which means that on the right side, I do have 0 now. And I've got sine of x plus sine of x makes 2 sine x. And then I've got plus the square root of 2 equals 0. Now, again, my objective is to solve for x. So I'm going to take this root 2 and move it to the other side of the equation. So I get 2 sine of x is equal to negative the square root of 2. And then, again, isolating the x, you're sort of like getting rid of everything next to you, and you're undoing all the properties. So this is times 2. I'm going to divide by 2 on both sides. So dividing by 2 on both sides does cancel this 2 out. And I now have sine of x is equal to negative root 2 over 2. And getting the x by itself and moving the sine over to the other side becomes arc sine. That's its inverse. So arc sine of negative root 2 over 2 is saying, where is sine negative root 2 over 2? So where is it negative root 2 over 2? So think of an axis, right, our unit circle. And all the way around our unit circle, sine is negative. They want negative. So that means sine is positive in both of these quadrants. So that's not an option. We're just talking about where is it negative. So it's negative in this quadrant, and it's negative in this quadrant. Do not drop down. That we're not using the restricted domain because that would be a negative value, right? Do not do that, and I'll show you in a second on another option. But this is saying, where is sine negative root 2 over 2? And so within 0 to 2 pi. So it would be 1 and a fourth. So you know that that's a fourth, right? Pi over 4. So that's going to be x equals, we've got a 1 and a fourth. Let's see, 1 and 1/4 pi is 5/4 pi. So 5/4 pi. Also, it's 1 and 3/4. So 1 and 3/4. So what is that? 5, 4, 5, 6, 7 pi over 4. And so these are my two solutions. Now, I do feel like it's important to mention that if I had given you this question, like this, where is sine negative root 2 over 2? And I just said, find the exact value. You would know that this has a restricted domain, and my restricted domain would be from here to here. This would be out, and when I'm asking you where is sine negative root 2 over 2, that would be down here. And that would be at negative pi over 4. Okay, and so it's really important that you understand that when they're saying a restricted domain, or I'm just giving you an exact value, and I don't say, hey, it's between 0 and 2 pi, then you have to use the values from negative root 2 over 2 to root 2 over 2. And I just want to show you one last thing. If I say my answers are from 0 to 2 pi, this is just one more way of thinking of it. I'm thinking of my values as a sine wave from here to here, right? But sine's restricted domain of negative pi over 4 would be outside of 0 to 2 pi, right? It would be over here at negative pi over 4. So you cannot use a negative value if your restricted domain is only between 0 and 2 pi. Okay, so heads up on that. This one is saying, again, only solve from 0 to 2 pi, not the restricted domains that we did in the beginning of the problem. Now, again, your objective is to get x by itself. One of the things you need to realize is that when you see a squared term here, this is quadratic. Okay, which means my first thing I need to do is set this equal to 0. So I'm going to do that. So I get 2 sine squared of x, move the cosine, minus cosine of x, minus 2 is equal to 0. So I've set this equal to 0. This is quadratic. The only problem is I can't factor this because I'm using, it's like factoring x squared, it's like factoring 2x squared minus y minus 2. Okay, it's like doing that. You've got a sine and a cosine. So you have to recognize that, I can't do that. I need to use one of my Pythagorean identities to replace my sine squared. This right here needs to go because I can't lose the cosine because it's not a squared. I can only get rid of the squared values because those are the only ones that I have identities for. And so this sine squared, remember, this is going to stem from sine squared of x plus cosine squared of x equals 1. So that means that sine squared of x is equal to 1 minus cosine squared of x. And so this right here is going to become 1 minus cosine squared. So we have 2 times 1 minus cosine squared of x minus cosine of x minus 2 equals 0. And so I do need to distribute. I get 2 minus 2 cosine squared of x minus cosine of x minus 2 equals 0. Oh boy, 2 minus 2 is going to go away. I love that. I also can factor, but now I don't have a trinomial. I have a binomial, which means that just having negative 2 cosine squared of x minus cosine of x equals 0, I can just factor out a cosine. I'm going to factor out a negative cosine. Negative cosine of x times, we're going to have 2 cosine of x. I factored out a negative. So that means plus 1 equals 0. Now let me make sure. Negative times positive is negative. Negative times positive is negative. Okay, I'm good. And so right here, we have to split this up. And now we set both sides equal to 0. So this is negative cosine of x equals 0. And this is 2 cosine x plus 1 equals 0. So on the right side, I've got 2 cosine of x equals negative 1. I'm going to divide by 2. Cosine of x equals negative 1/2. And then x is equal to arc cosine of negative 1/2. Now, arc cosine of negative 1/2, they're saying, where is cosine negative 1/2? And remember, it's not in a restricted domain because I have all values from 0 to 2 pi. So cosine is positive in this quadrant and this quadrant, so those are out. So I'm going to be here. So where is cosine negative 1/2? Cosine is adjacent over hypotenuse. So negative 1 over 2, which means that's a root 3, which means that's 60 degrees. So 60 degrees is not my answer. That's just my reference. So I'm going to go from here to here, and that's 120 degrees because that makes 180. So one of my answers is 120 degrees, or I could say 2 pi over 3, either one, 2 pi over 3, if you think in radians or degrees. And then also, I'm down here, same reference angle, right, 60 degrees, but now it's 180 plus 60, and 180 plus 60 is, what is that, 240? Yeah, and so also 240 degrees. In radians, it's 1 1/3. So 1 1/3 is 4/3. So 2/3 and then 4/3 pi. Also, don't forget this, okay? So I now have to say, divide by negative 1, that's gone. So now I have cosine of x equals 0. 0 divided by anything is still 0. So now I'm going to move the cosine to the other side. I have x equals arc cosine of 0. They're saying, where is cosine 0? And so where is cosine 0? I mean, some people like put the unit circle, put points on. So 1, 0, 0, comma 1. This point is negative 1, 0. And this point down here is 0, comma negative 1. Other people look at it and they go, well, I like to draw a graph. I actually like to draw a graph. And a cosine wave does this. And so it's very easy for me to say, see, so this is 2 pi, this is pi, right? Where is cosine 0? Well, cosine is 0 here and here, which is pi over 2, which is 90 degrees. Also here, which is 3 pi over 2, which is 270? Yeah, and 270. So here are all the answers for my equation. And yes, you have to list all of them. So if I was listing all of them in radians, I would say 2 pi over 3. I'd say 4 pi over 3. I would say 90 degrees, which is what? Pi over 2. And I would also say 3 pi over 2. And so all of those answers would be correct. Just keep in mind that had one of my answers been 2 pi, you can't use 2 pi because remember, from up here, from my the values that they said I had to solve for, a parenthesis means not including. So it's not including 2 pi, everything else. Cool. This says solve for all values, again, 0 to 2 pi, not including 2 pi. Your objective is to solve for x. I noticed that there's no x. Let me put one in there. Hold on. Okay. So I'm going to solve for x, which I've just added. And so just kind of unravel it. First thing I'm going to do is move the 1 over. So I get 3 times tangent squared of x equals 1. Get rid of the 3. That's 3 times that. So undo times by divide. So divide both sides by 3. So now I have tangent squared of x equals 1 over 3. How to undo a square root, how to undo a square is you square root it. So we're square rooting both sides. So you go tangent of x is equal to plus or minus, and this is going to be root 1 over root 3. And square root of 1 is 1. So that's going to change to root 1 plus or minus. So I get x is equal to arctangent. Remember, you got to solve for x. So arctangent of positive 1 over root 3, and x equals arctangent of negative 1 over root 3. And don't forget, that root 3 on the denominator, we don't like that. We want to change that to arctangent of root 3 over 3, and this one is going to become arctangent of negative root 3 over 3. And if you remember, right, root 3 over 3, 30. 30 degrees is my reference. So it's got to be a multiple of 30 degrees all the way around, because this is saying, where is tangent root 3 over 3? Positive. This is saying, where is tangent negative root 3 over 3? So it's everything all the way around, not including 2 pi. So a 30 degree reference here is pi over 6. A 30-degree reference here is going to give me, what is that, 5 pi over 6. A 30-degree reference in this quadrant is going to give me 1 and 1/6, which is 7 pi over 6. And a 30-degree reference in this quadrant is going to give me 1 and 5/6. What is that? 1 and 5/6, and that's 11 6 pi. And so my answer would be x equals, and it would be, just put all those values down. Pi over 6, which is 30. 5 pi over 6, if you're doing degrees, 5 pi over 6 is, what is that, 150? This one is 180 plus 30, that's 210. Or you'd say 7 pi over 6. And also last is 11 pi over 6, which is 330. Okay, cool. For this problem here, solve for all values 0 to 2 pi. Again, another equation. Your goal is to solve for x, or in this case, theta. So unravel it. First, I'm going to move the 4 over. I've got 4 sine squared of theta equals 1, because I subtracted 4. And divide by 4, I get sine squared of theta equals 1 over 4. And to undo a square, again, square root it. Don't forget you are going to get 2 answers because it's a square, just like a quadratic. So we get sine of theta is equal to, and this right here is the square root of 1 over the square root of 4, right? Which becomes 1 over 2. But don't forget, it's plus or minus 1/2. So my 2 answers are going to be theta is, or my 2 continued solutions are theta equals arc sine of positive 1/2 and theta equals arc sine of negative 1/2. And so therefore they're asking me on a axis, where is sine a half? All the way around, not including 2 pi. And so it would be here at pi over 6. That's a sine. Oh, it's all the same answers as the tangent one. I love that. And so that's going to be x equals this pi over 6, because it's positive here and it's positive here. So this would be 150 degrees, which is 5/6 pi. It would be negative in this quadrant down here, which is 1 and 1/6, so 7/6 again. And then this would be negative down here in 11 pi over 6. So again, just the angles are 30 degrees, 120, and third quadrant would be 210. Oh wait, hold on, that's not 30, that's not 120, that's 150. Sorry about that. 150, 210, and 330. All right, right on. So the last group of problems, I thought they were solving, but they're not. They're proving identity. So there's a couple of these. When you see a problem like this, what you're looking at is trying to make the left side equal the right side. You are only going to work one side of the problem. That's it. And so working one side of the problem only, okay, only. I'm going to work the left side of the problem because you want to try to work the problem that is going to be the most difficult, okay? And it looks like this left side is going to be trickier than this side. So to get rid of this add on the bottom, I'm going to multiply by its conjugate, which is 1 minus sine of x over 1 minus sine of x. Now a conjugate is good because what it does is it loses any kind of roots or anything on the denominator. It's like a difference. It becomes a difference of 2 squares. And so think about distributing. So I've got cosine of x times 1. I'm going to leave it away from right now, just for 1 second. I don't know what, I'm going to leave it like that on top. But on the bottom, 1 times 1 is 1. 1 times sine is sine. Negative sine times 1 is negative sine. Those cancel out. And then I'm left with minus sine times sine, which is not sine squared. Okay, and so this is a quantity. Do not start canceling those. You cannot do that. They're different. This is sine of x, this is sine squared of x. Do not cancel those. But what you can do in the next step, which I'm so glad I didn't multiply that through, because I see that the bottom, the denominator down here, if you think about it, remember this, sine squared of x plus cosine squared of x equals 1. If I move the sine squared over, I would get cosine squared of x equals 1 minus sine squared of x, which is cosine squared. So this becomes cosine squared of x, right? Well, what that means is that one of my cosines is going to cancel with one of them down here, leaving me 1 minus sine of x over cosine of x, which, hello, is exactly what I want to prove. And so therefore, at this point, when you make the left side equal to the right side, you bring this all the way down, and then you say, okay, that equals 1 minus sine of x over cosine of x. You box that up, and you kind of check it. Yep, it's done. That's how you do that. Uh-oh. Uh-oh. It seems like I have a negative. I think I'm going to have to, what are we going to do with that? I'm not really sure if this is supposed to be a minus or plus. I'm going to make it a minus for right now, and we're going to see what we get, okay? Just a note, on the left side, actually, let's work the right side. Let's work the right side. If I was working the left side, the first thing I would do, just saying, is 1 minus cosine of x over 1 minus cosine of x. I would do that, and I would distribute. But I want to see what this right side actually is equal to before I do this on the left. And so I'm going to work the right side instead of the left, okay? So the right side is actually 1 over sine of x minus cotangent, which is cosine of x over sine of x. Oh my gosh, this is so easy. My denominators are exactly the same. So I'm going to make that sine of x. And then on the top, 1 minus cosine of x. So it looks like, oh, that's not the same. Darn it. So it does look like this is equal to 1 minus cosine of x over sine of x, right? So that's where I'm going. I'm going to work the left side because I'm done on the right side. I'm done. And so I do actually need to work the left side. Okay, so let's do that. Let's see. In doing this, let's see. I'm going to go sine of x times 1 minus cosine of x. And on the denominator, when I multiply by 1 minus cosine of x times this, I get 1 minus cosine squared of x. And remember our triple, our Pythagorean identity that we had, 1 minus cosine x actually is equal to sine squared of x. Okay, and so I'm going to leave this out, sine of x here, and this is 1 minus cosine of x, okay? Now, where I'm going with this, okay, I'm going to erase that so I don't get confused, but I do see 1 sine of x can cancel with one of these. And so now I have 1 minus cosine of x over sine of x. Now, this is equal to this on the right, but it's not in the right form yet. So I have to keep working the left side, work one side. But I do see that my denominator does go to both of my numerators. So you know how you usually combine the denominators so you can add the numerators? We're actually going to split them apart. And so we're going to go, this is 1 over sine of x minus cosine of x over sine of x. And 1 over sine of x is actually cosecant of x, and cosine of x over sine of x is actually cotangent of x, which is, hello, what we are trying to prove. So minus cotangent of x. These are the same. You're going to box that up, and you're going to go, check. We did it. All right. I think this is the last problem. It is. All right. For this problem, I mean, Pick what you want to do. You want to do the left side, you want to do the right side. On the right side, I am going to end up with what's 1 over secant. That's going to be 1 over cosine, and cosecant is 1 over sine. So ultimately, that's what I want to get, right? Something like that. But let's do the left side, because that looks like a little bit trickier. The left side is tangent, so that's going to be sine of x over cosine of x, plus cotangent, which is cosine of x over sine of x. And then because I have two terms on the left, and I look on the right and I say, hey, that's one term, then what I'm going to do is try to combine these two terms. So my common denominator is going to be sine, cosine. So this needs a sine. Give me a sine. This one needs a cosine. And now that my denominators are exactly the same, my denominator is sine of x, cosine of x, okay? On the top, I end up with sine squared of x plus cosine squared of x, which we know is 1. And so now I'm 1 over sine of x, cosine of x. Still don't have the same right side, because remember, you're only working one side. But I can split the numerator up to two denominators, which is 1 over sine of x times 1 over cosine of x, and that 1 over sine of x is cosecant of x. 1 over cosine is secant of x, and secant is the same as secant, cosecant, and so therefore these are the same on the left and the right. Right on. And we just box that up, go check, and that's it. That's the last problem. So I wish you the best of luck on your test. Thank you so much for watching all the way to the end, and see you in class. All right, right on. Good luck. Okay.